Hello there everyone, my name is Ahmed. I'm the founder of the Dope Code channel. Hope you will doing fine. So this is a crash course about Python. In this crash course I'm going through all the fundamentals and basics of the Python programming language. I'm not digging into any advanced topics like object-oriented programming or anything like that. Here you're gonna find all the things you need to learn the basics of Python. So if you are an absolute beginner or intermediate level, or just someone who wants to brush up on their skills and remember Python again, then this is the right video for you. Yeah, I managed to combine all the videos that I have in the Python playlist that already exists in the channel. You can check it out if you want. I thought about doing this because I myself like watching all the tutorials I need in one video. I'm sure there are people who like the same thing out there, so here you go. This is for you guys, and yeah, I hope you like the video, and if you have any thoughts, just leave them in the comments below.
First of all, here is how you write a comment. You do this hashtag sign, and whatever you type here doesn't get executed. Well, for example, print 1 2 3 4 5. When I execute this hitting Control P on Windows, nothing happens here. You don't see anything printed here in the console. But if I do the same thing in the next line without putting a hashtag symbol before, you'll notice that this 1 2 3 4 5 gets executed and printed in the console. And the main reason why the Python team decided to add this comment is to help developers who work in teams to understand their code, and for you as well. I mean, when you are further down the code and you've spent a lot of time coding and you have more than 1 or 2 files, then having comments like this will be necessary. For example, we can describe what we've done right here by typing the next line print 1 2 3 4 5. Well, it's crystal clear that it does so, but you know, you should also know where to use them and why you should use them. Anyways, this is how you print something in Python. It doesn't matter what you print, either a number or a text. We'll get to the variables and all of that later. This video is only concerning this print function. And to end this video, we'll have to do the typical the typical print statement that every single developer had to start with. It is the hello world. There it is. And with no, I forgot to say, in Python we don't use semicolons at the end. We don't add any semicolons at the end, just like this. And that's one of the advantages of Python. You don't have to end your line with a semicolon. All what you need to do is to print whatever you want to print, and that's it. You don't use curly brackets like this, yeah, which can really be bothersome when you have tons of files. But yeah, there are other problems with Python, of course, like indentation. If you forget to add indentation or something, then an error will come to your face and slap you. Yeah, you know what I mean. So in this video we're going to be talking about variables and data types. And by the way, in the last video we had a task to print this statement, the hello world, the typical print statement, and I ended the video without doing so. So let's get that done right now. Hitting Control B. Now we're good. Hello world. Alright, let's start with our video. Let me delete this. Alright, so what are we gonna be talking about today are variables and data types in Python. So they are built-in data types in Python and programming in general. So those data types are really important. They are an important concept. Variables can store data. They are like a box that contains some kind of a data type. There are lots of kinds of data types: strings, numbers, data structures. There are a lot of them, and we're going to go through each one of them. Well, variables, as I said, can store data of different types, and different types can do different things. So Python has the following data types built in by default. The first one is the string data type. When you hear string, what we mean is anything that is wrapped by either double quotes or single quotes. It doesn't matter, you can choose whatever you want in Python. It doesn't put constraints on you, not like other languages. So this is what a string is. It's just like a text, anything. You can put a number here. This number is different than the other number we're gonna discuss later. This number means that this is a text, something that you type. It doesn't mathematics doesn't apply in this. Like, I can't add this number with this number. If I do this, an error will occur. Well, not an error. Actually, what's gonna happen is this. What's gonna get printed is a long string of numbers, as you can see here. Well, of course, this number plus this number isn't equal this. If I want to see the real results, I just have to remove these quotes and hit Control B again, and this is the math. Well, enough with math for now. As I said, well, what we saw here are strings, and strings are just text. With that out of the way, let's go to the next data type, and those are numeric types. They are integers and floats and complex numbers. I guess that came with the latest version of Python. But in this video, let's cover integers and floats. So integers are just like real numbers that don't have like a fraction or something like that. For example, 1 is a real number, 2 is a real number, 3 is a real number, and so forth. But 1.5 or 1.2 or something like that, that's called a float, and the float is different than an integer. I mean, they can add up together just fine, but in some situations you just have to use integers if you need to use integers, and use floats if you need to use floats. So what we covered so far are strings. Strings are just text, any text, and integers are numbers like 1, 2, 3, even negative numbers like -5, -10. We covered floats. Floats are numbers that give fractions, like when you divide 1 over 2, that gives you 1.5. 1.5 is a float. 2.8, 3 point something, anything. Just when you see a point, that means that you have a float. They're also known as doubles in other languages. And the other data type is the Boolean types. Booleans are either false or true, nothing else. They are just two values for a Boolean. Either true, well, we have Boolean, they are either true or false. That's it. In Python we have to use capital case, true or false, just like that. And what else? We have data structures like sequence types. Sequence types, they are basically three. These are lists and tuples, and also a range. Well, let's see some examples. Well, let me remove this so we don't get an error. Let's comment all of these. Alright. Here, as I said, there are other types like data structures. Some of them are called lists. Lists are like a collection that contains a couple of data types, different ones. You can just put lots of variables inside a list. We denote a list by these brackets, these squared brackets, and here you can do whatever values you want. It just contains all variables you have. It does contain different data types, doesn't matter whether it is text, booleans, floats, or numbers, text, anything can be printed here. And if we print this, we're gonna get the following. We also have tuples. Tuples are the same as lists. Instead of using square brackets, we use parentheses, just like this, parentheses, and that means that we are using tuples. And the difference between tuples and lists is that lists are immutable and tuples are immutable. That basically means that once we construct a tuple, we can't change it anymore. But here in lists, we can tap into these values and change them however we want. Well, of course, we're gonna make other videos concerning data types, each one individually, like a video for text, integers, booleans, and definitely lists and tuples. This video is just covering all of them, giving an overview and what like. So we have other data sequence like range. A range is it's more like a list, but you give a start value and an end value. Like this range will start from 1 and will end in 20. Here, if I print this, it's like I get a list that starts from 1 and goes through 2, 3, 4, 5, 6, 7 up to 10, just like this. And of course you can print it here unless you are using a for loop or something, but this range contains all the values we need from 1 to 20. We also have other values like sets and frozen sets and dictionaries. Dictionaries are like key value types. You basically define a dictionary like this using curly brackets. You give it a name, for example, name, and it takes a value like Mike or something like that. The keys and the values can be whatever data type you want. It doesn't have to be necessarily a string. It can be a number like 1, consists of 1. And if we print this, we get the following like this. And we can tap into each one of the values by calling the name of this dictionary. First of all, let's assign it to some variable. Let's just call it dictionary. Dictionary is equal to this list. And if I want, for example, to print this Mike name, all I have to do is to get this dictionary and do like this, open two square brackets and call the value I want to get by its key. For example, I want to get this Mike, then all I have to do is to use the name, this name, because this is the key of this value, just like this. And if I hit Control B, I get Mike here. The same for the other value. I just have to tap into this value using this key, which is just a number. Here I just put 1 and Control B, I get 2, because here 2 is the value of this key. Well, this was just an overview. We went through the most important data types in Python. We are going to make other videos concerning every single one of this, as I said, because this is a very important thing and we have to get the grasp about everything here in Python. This is the fundamentals, like the pure basics. If you get the hang of all of this, then you are all set to go. Well, that's it. You can get the data type of any object by using the type function. The type just tells you what is the type of the variable you have. For example, we have this variable, let's call it variable for sure. Here, let's assign a text to it. Let's call it text. Here, if I want to know the type of this variable, all I have to do is to print its type. I just type type like this. I open brackets and the name of the variable I have, which is variable. You can name it whatever you want. I hit Control B. I get this class string. We'll get into classes later. That's a more advanced topic. It's out of the range of this video, but yeah, here it's called string. This str is just an abbreviation for string. For example, if we have here a number like 148, we get an integer here. As you can see, int, short for integer. Whatever you do here, a list works the same. Tuples work the same, dictionaries work the same, they all work the same. Here, as you can see, this is a list just because I wrapped this number with this squared brackets. Well, basically this type, it's helpful, it just lets you know what is the type of your variable. That's all it does. So I guess I'll have to wrap up this video here. In the next video we're gonna be talking about every single one of these. We'll start with the strings and we'll dip in further, discuss more related topics about strings, how to concatenate strings together, how to go through every single character and how to split them, join them, all things concerning strings. And after that we'll jump into integers, floats, and until the end of this list. Last video we talked about data types and variables in Python, and I made a promise to talk about every single data type of these individually. So in this video we'll be talking about strings. So let's get started here. Well, strings, as I mentioned before, are just text, nothing else. When you think of strings, you think of some characters like this who are wrapped in double quotes or in single quotes. This is how we refer to strings. Just like this, you can use whatever quotes you prefer, doubles or single, doesn't matter. So in strings we can concatenate strings, like add this part to this part like this. For example, if I want to print this plus this in one string, or let me change the string, this one is horrible. Alright, for example, here Mike and Smith, we have two strings. We want to print one single string that contains this string and this string here. All that we have to do is this following: we just make use of the plus symbol, nothing else. Well, let us first assign these values to some variables. Let's call this v1 for variable 1, and this is v2 for variable 2. So we have two variables, each one has a unique value of a string, and if we want to print this one plus this one, we just do the following: v1 plus v2. If I hit Control B, I see Mike and Smith just in one single string, but we notice that there is no space. We can add space if you want, like here. This solves our problem. Or the same thing, you can just add it here at the beginning of this Smith string, and the same happens here, the same thing gets printed. Or we can come here and add another string that has nothing inside of it but a white space, just like this. And if I hit Control B, the same happens here. Well, now we're talking about strings, and as I said, we'll talk about integers and floats and booleans in other videos. So let's go back here. If I want to print every single one of these characters that make up this string, You have to understand something first. Strings are numbered. Every character of a string has a unique number. For example, this M is a number 0, this number 1, this number 2, this number 3, and so forth until the end of the string. So if I want to get the first character, all I have to do is to refer to it by its variable name, open square brackets, and calls by its number. We said that this is 0 like this because in programming we start from 0, not from 1. If I hit Control B, I get M because this is the first character here. If I want to get this, I just have to calls by its number, which is 1. Here I get I. For example, I want to get this part MI, then I need the character number 0 and the character number 1. I can do this if I want, like 0. This prints M, and here I can, well, here can do v1 and tap into the value of the number 1 and get this mi like this in one string. But there is another easier way to do the same thing. Here I refer to the variable by its name, v1, and I specify the start value and the end value. Here we start from 0, go to 1 and 2. We stop here, so I have to go from 0, 1, 2. This will get me this part. Here I see that's 0, then I separate it with a comma and type 2. This will print the same thing. Control B gets you my, and I can, for example, get this part just by increasing the number here, incrementing it by 1. And here I get this. And if I want to get the entire string we have here, I just have to call all the characters from 0, 1, 2, 3, 4, and that's it. But it just goes like this and make life much easier. If we want to get the length of this string, like how many characters make up this string, we can use a function called len, short for length, and here we type the name of the variable. For example, this v1 contains 1, 2, 3, 4 characters. Therefore, the length of this v1 will be 4. Here I expected, and same thing can happen for the other string v2. Here it contains 5 characters. Well, as I said, these characters are numbered from 0 to the length of this string. Like this is 0, 1, 2, 3. But if we want to start in a reversed order, we calls from here. For example, we start from here instead of here. Then we don't start from 0, we start from -1. This is -1, this is -2, this is -3, this is -4, just like that. Let's see some examples here in this v1. If I want to get this e, I just have to call by -1, and as you can see, well, let me remove this link first. Here we get the last character of this string, which is the letter E. And if I want to get this this letter, I just have to decrement it by 1, and -2 will get me the letter key. There you go. Well, this is it about strings. You can also manipulate the look of the strings by calling it with some built-in methods. Like, for example, I have this variable 1. If I want to print this in lowercase, all the letters will be in lowercase. I do the following. I just call the lower function like that, and I get everything here in lowercase. You see this letter here, it's in capital case, but here it's in lowercase, just like that. Now if I want to print everything in uppercase, and you might have guessed this, I just type upper here. Here you get everything in uppercase. And for example, if this was in lowercase, and I want to print it, and like it was before, I just type title here in the form of a title, and it gives me the first character capitalized. Yep, that's it, I guess. And what else have we covered yet? Let me see. We also can manipulate a lot of other stuff in strings. We can split them and join them together, but that will mean that we have to use lists, and we still haven't covered lists yet. We just gave a brief overview about them in the previous video, but once we make a video about lists, then we'll talk about the chain of characters and how can we like split this tree in half or join them together. In this video we're going to be talking about integers, and the last one we've talked about strings, and we saw some examples. We left it here. We saw some examples here, and we went through strings. If you didn't watch the last video, then I suggest you go back and watch it. In this video we're going to be talking about integers. Integers are basically just real numbers. They are whole numbers, positive or negative, without decimals. They're also of a limited length. They're not like floats, because floats have point numbers, and they also can be positive or negative, but they contain one or more decimals. But integers, they don't contain any decimals. They are just real numbers, fully without any decimals. For examples, integers. For example, we have this x variable. I'll assign to it a positive number, for example 1. This one is an integer, just like that, because it is a real number without any decimals, and it is a whole number, of course. And for example, negative numbers are also integers, even though they are negative, and it doesn't matter. All what matters is that they shouldn't have any decimal point like this. For example, this number here, this is a float, not an integer. An integer just shouldn't have this little dot over here. That's it. If you don't have this dot here, then you have an integer. As I said, well, this negative number is also an integer. Also, low numbers that contain a lot of digits, those are also integers, like this number right here. You see this whole string, it's also an integer. And to make sure that we are on the right page, let's try and put this type function that we've discussed in the first, I believe the second video. Yeah, go back and see it if you forgot. Well, the type of x and the type of y and the type of z, they all should give us integers. Yeah, hit Control B, and as expected, they are all integers. And as in mathematics, you just have to know basic arithmetic, just elementary school stuff, if you want to do some mathematical operations here, like for example, add integers. Like, you know how to add integers, you just add this integer with this integer and you get another integer. Just the basic math. You can assign all just basic operations, like the addition, the subtractions, multiplication, the division, and all of that will be talked about in another video. Well, integers, for example, if I have here this number which is negative, let's call it v, short for variable. This is a negative number, and I want to get the same variable but positive. Then I can use a built-in function inside of the Python library called EBS. All it does, it gives you the positive value, the absolute value of this variable here. Now it's negative, but when I surround it with this EBS, short for absolute value in mathematics, if you still remember, then it will give me the same number here, but without a negative sign. It can be handy sometimes. Well, if we don't have a negative sign here, we're just going to get the number exactly as we have it right here. Yeah. Well, integers are not really that difficult. They are just numbers. Just think of normal numbers. Just they don't contain decimals, and that's it. That's all what you have to know. Well, that's it for this video. I like to keep my videos short, nice and concise. In the next video, we'll be talking about boolean. No, actually, I will be talking about floats, and then we'll talk about booleans. Hello there, dope coders. I hope you all doing fine. So we're going to proceed in our Python tutorial series. In the last video we saw integers, and we've discussed that integers do not accept decimals. They can be either positive, negative, have unlimited length. Whatever digits you want to put here, just put them, it doesn't matter. Even a zero can be an integer, why not? In today's video we're going to be talking about floats, so if you didn't see the last video I suggest you go back and watch it so you stay in the loop. Well, floats are basically sort of the same like integers. They are at the same time opposite to them. Like for example, we said that integers do not accept decimals. Floats do. Numbers that are can be considered as floats are like well, let's some examples. 1 divided by 4, that's a float. Also, like for example 1.6, that's a float. For whatever number you can think of, just, well, look at this variable name, how strange. Alright, 3 point something, that's also a float. And let's print some examples here. Alright, if you like for example want to make sure that this is a float, and this is a float and this is a float, all you have to do, as you might have guessed it, we just have to print the type of the variable we have right here. That's exactly what I'm going to do right now. Here it is. If I hit Control B, I see that it's a float. I guess you got the point. Floats are sort of like integers. The only difference here is that floats accept decimals. Here you can put a dot here, and whatever digits you put here doesn't matter. But if you have like numbers just like this is an integer, and that's what we discussed in the previous video. So this is it. Floats are integers but with decimals. That's all what you need to take from this video. As for this video, we're going to go through booleans. Yeah, so in the Python boolean type is one of Python's built-in data types. It's used to represent the truth value of an expression. For example, the expression that I'm going to type right now, which is 0 is less than or equal to 1. This is how we say that 0 is less than or equal to 1. Just like this, like in math, this symbol means less than, and this equal sign means less than or equal. So here I'm seeing that 0 is less than or equal to 1. Well, in basic mathematics, this should result to true, because 0 is less than 1. That's the norm, right? If we print this expression like this, we should get true, because that's what it is. It is a true thing. But if I do this expression here, 0 is equal to 1. This is how we refer to two values being equal. Like here I'm saying that 0 is equal to 1. The value here is equal to this value over here. Of course this should give us false, because 0 is never equal to 1. So when I hit Control B, I see false printed on the console. So understanding how Python boolean values behave is important to programming well in Python. And there are basically just two possible values of booleans in Python: true and false. And both these values, the first letter has to be capitalized. This is the convention in Python. You can't just type true or false like this with a lowercase f and a lowercase t. Both those letters have to be capitalized in order for the interpreter to interpret the values without giving us any errors. So the type of both false and true should result to bool, and we've gone through the type function in the previous videos. All what we basically have to do is the following: we'll print the type of true and the type of false. Both these expressions should give us the same result, which is bool. Bool basically stands for boolean. So if I, for example, assign some variables over here, like v1 for variable 1 equal to 1 equal to 1, which is a true value because 1 is equal to 1, it's the same value, and v2 for variable 2, here I'll put 2 is greater, is strictly greater than 0, which is true, but I want it to be false, so I'll say that 2 is strictly less than 0. This should result in false. If I print the value of v1 and v2, I should get true and false accordingly. So let us do so. I hit Control B, I get true and false, and if I like I did earlier, print the type of these two variables, I should get bool because they are both boolean types. Well, although technically possible to avoid confusion, it's highly recommended that you don't assign a boolean value to some variable name that is called bool. Like for example, if I did this, bool is equal to 2 is assigned to 2 equal to 2. This should give us a true value, but it's not recommended to use the bool as a name for a variable because we have it here as a class name. We'll discuss class later. It is out of the scope of this video. So if I type here bool, I should get well, this will give us true, this false, and this true. So if I hit Control B, this is what I get. Here I get the type of these two variables, and here I get to, well, it's not recommended as I said, because even though this doesn't result in an error, it's always good to avoid confusions. So built-in names aren't keywords as far as the Python language is concerned. They are regular variables. If you assign to them, then you will override the built-in value. That's why just use some kind of name. Any name will do, like here is to equal to 2, like this. Always when you are using a boolean expression, you start the name of your variable with a question like is, are, and just like that. Well, these are booleans, just values. There are two, just false and true. Those are the only values for booleans. In this video we're going to be talking about Python arithmetic operators. So let's get started. Well, arithmetic operators in Python are basically sort of the same like our old vanilla arithmetic operators that we are used to do in math. There are basically 7 of them. They are used to perform mathematical operations like addition, subtraction, multiplication and division. There are also others like modulus and exponentiation and full division. So we're going to cover each one of them one by one. Let's start by talking about the addition operator. So we refer to the addition operator with the plus symbol. This is the addition operator we use it in order to add two numbers or even more than two numbers together. Like for example, I have this v1 give us a value of 4 and v2 a value of 8. When I do v1 plus v2, just like in basic math, I'm adding two numbers together, nothing new here. I use Control B, I see no errors because this is known in the Python library. So if I print if I print v1 plus v2, I should get the addition of those two variables, whatever that is. It's 12. And just like that, this is the addition. You just add two numbers together. You can add more than two numbers. Like for example, if I have a third variable here, let me call it v3 and give it a value of 10. So if I add v1 plus v2 plus v3, I should get 22, just like that. Come on, hit Control B, and I get 22. Well, this is the addition operator, and if you've guessed this already, the subtraction operator is the negative sign, this sign. So just like in addition, we just define some variables here, v2, 40, and we basically subtract the second value from the first value. We just take it away from it, just like in normal math. So if I do print v1 minus v2, I should get 5, just like that. It's easy peasy. And the third one is multiplication. In multiplication, we use the asterisk sign in order to refer to multiplication. So basically when I do this, v1 gives v4 and v8, the first values. If I do v1 asterisk v2, all what I mean is v1 times v2. So I just have to get the multiplication of these two variables right here, which is 32. This is how we refer to the multiplication operator. It is used to find the product of two values, just like in normal math. And the fourth operator we're going to discuss is the division operator, and we refer to that by this symbol, just say /. So if I do 4 / which stands for the division operator, and v2, it's like I'm saying v1 divided by v2. So when I hit Control B, I get 0.5, it floats. And if I wanted to get a number, an integer, without having to include this decimal parts of a number, I just have to use this two /, and I can get this value right here without any decimals. For example, if I have 1 divided by 2, if I do the normal division operator, I get 0.5, but if I add another / here, I should get 0. The 0.5 doesn't appear because it just gets rounded down to the latest value. The next operator we have is the modulus operator, and which is in Python used to find the remainder when the first operand is divided by the second, and we refer to that by this symbol right here, just the modulus operator. It is used to get the remainder. So if I do like 2 v1 remainder of v2, I get this value because 2 only includes 1 of itself, it doesn't include anything else. But if I do like for example 4, how many 2's are in 4? I should get 2. Oh well, or just a 0. Well, I don't know modulus that much, so don't pay attention. Anyways, so the exponentiation operator is like multiplication. We use it to find the raise of the first operand to the power of the second. Like if I want to find the power of 4, like the power of 4 of 2, all I have to do is v1 and two symbols like this, two asterisks. It's like I'm saying 4 to the power of 2, which is equal to 16, I believe. Yeah, this is how we refer to the power of something, like here 4 to the power of 2. How does it equal? It does equal 16. And we have the floor division. The floor division is the one that I've talked about earlier when I discussed the division operator. It is this symbol, two forward slashes, and by that we sum this video right here. These are the arithmetic operators, just the normal ones we are used to in elementary school, nothing more, nothing less. Hello there everybody, I hope you're all doing fine. So in the last few videos we've gone through the very basics of Python. We covered data types and arithmetic operators. We also gone through some handy functions like the type and the absolute functions. And in this video we're going to cover something a little bit different. We're going to talk about data structures and collections in Python, and specifically we're going to cover the list data structure in Python. So the way you can think of lists, like imagine with me you have a lot of variables and you want to store the data of these variables in a collection, in a box, so they are stored there and you can manipulate the box and know how many items there, in our case variables, and you can manipulate that list however you like. So let's go through some example so that this notion sink in. Alright, for example, we have these variables, variable 1, let's make it an integer. Also, let's can store all kinds of data types. They don't have to be specifically one data type, like just integers or strings. They can be various. You can have integers, booleans, whatever data types you want to put there. And also, let's store data in order, so you can call them in order sequentially. You don't have everything randomized in that list. Well, variable 2, let's give it like 10, and let's add another variable. Let's give it a boolean value. Here I have this list. Let me call it L. This is how we refer to lists. We just open two square brackets like this, and whatever data you want to store, you just put it here inside. So I'll put v1, and we separate it with this comma, v2 and v3. You can add other variables here, for example 1.5. Here, if you want to print it, you simply use the print function. L. If I hit Control B, I see a list here with all the data that I stored inside. And if I want to know the count of this list, how many items are in this list, all what I have to do is to use the len function that comes with the Python library, len, and I open two brackets and I put inside the name of the list I want to know the length of. So I type L and it's Control B. I see 4 printed in the console because I only have 4 variables here. If I have more, I will get more, 5. If you want, like for example, to sum the values of that are inside this list, you make use of the sum function, which does nothing but give you the sum of all of these variables here. But here we'll get an error because we don't have only we have strings and booleans, and string and booleans can't be addable with integers and floats. If you want to get the sum of this list, we'll have to have another list which contains nothing but numbers, either integers or floats. So let me change these variables here to floats and integers. Here it's called L2 and the one above L1. So if I hit Control B, I get the sum of this list. And in the same manner, if I want to get the maximum number here, I just use the max function. It gives me the maximum number in this list, which is in our case 45. If I hit Control B, I get 45, and vice versa. If I want to get the minimum value here in this list, which is in our case 1, I just you might have guessed it, I use the min function. That's my min. It's Control B, and there you go. Well, if you want to get one value of these values, you have to know that items inside a list are indexed, meaning that we start counting or defining our items from 0 incrementally. So I can see that this one has an identity of 0 or index of 0. This one 1, 2, 3, 4, and just like that for us how many variables we have there. So like for example, I want to get the item in this list that has index 3. In our case, that will be 0, 1, 2, 3, 1.5. This one has the index of 3. And if I want to print it, I do the following. Let me come at this line. I refer to the name of the list I want to get an item in. Let's say for our case L2. I open two brackets and I put inside the index that I want to get its value. In our case, we said 3, which will give us 1.5. If I go through and hit Control B, I get 1.5. And the same goes for all the other values. If I want to get like the first value, I start from 0. Let's Control B, I get 1. And if I want like to use negative numbers, that will mean, well, when I see 0, 1, 2, 3, 4, that means that I am starting from right to the left. But if I want to start from the left to the right, I have to use negative numbers. In that case, number 3 will be indexed my negative 1, this negative 2, this negative 3, negative 4, negative 5, and just like that. So here, if I put negative 1, I should get the last number here, which is 3. And just like that. Minus 2 will give me the item right before it. 0.5. And that's it. So we can also add the lists together. Like for example, when we add lists, this list will get added to the end of this list. Basically, I will get one list that contains the items here and here in order. So if I do L2, L1, plus L2, I should get a list that contains all the items in both lists. Control B, and that's exactly what I get. And also, if you want to add some other variable to our list, like to the end of it, we just make use of the append function. This is what we do. Like we have L1. We want to add the value true to the end of the list. What we do is the following: L2, L1, append true. Just like that. If I print now L1, I should get the original list that we had before, which is this, and true is added to the end of it. And you can add as many variables as you like, and whatever data type, just like that. In the same manner, if you want to delete some value from our list, we just make use of the remove function, which is like this. For example, I want to remove this 1.5 from my list. What I do is this: I just refer to the function I want to the list I want to remove an item from, and I type remove, and I give it the variable I want to remove. It's Control B, and I get a list without the variable that I had before, which got removed. Now it doesn't belong to the list. Well, that's it, guys. Thanks very much for watching. Hope you liked the video. So look forward for future videos. They're coming soon. We'll be talking about other data structures like tuples, which are basically just lists, but immutable, meaning that they don't change. If we have a value there that we can't add to it or remove from it. And also there are dictionaries, which are also known as maps in other languages. We'll be covering all of those in the future. So in the previous videos we've gone through lists, we saw some examples and we covered some key functionalities that has to do with lists, like adding two lists together and adding values and removing values from lists. The thing is, we haven't covered everything about lists. There are still some stuff that we need to talk about, some built-in methods that we need to cover, and in this video, part 2 of lists, we're going to go through those exact methods. So let's get started. First of all, let us initiate some example lists here. Let me call this one list 1. Open my curly brackets and go to 1, 2, 3, 4, 5. Well, let me put some commas in here. I have these lists. If I want to get the first value of this list, as we mentioned in the previous video, all I have to do is to refer to the list by its variable name, which in our case is list 1. I open two square brackets and I type the index of the value that I want here. As I mentioned in the previous video, this list has index values, meaning that every single value of these values has a single index attached to it. For example, this one is indexed 0, this 2 is 1, 1, 2, 3, 4, 5, just like this, from the smaller value, which is 0, all the way up to the length of this list minus 1. In our case, we have 6 elements here, therefore the last one will be 5. We'll have the index of 5. It just happened that we have our numbers here in order. They can be just random order like this. It doesn't really matter. It doesn't have to be in order. Also, they don't have to be containing a single type of variables. It doesn't have to be integers only. There could be here we have like example strings, characters, floats, booleans, whatever have you. So if we want to get the first value here, we just refer to it by its variable name or index, so to speak, which is in our case 0. If I type 0 here and then hit Control B, I should get 3, which is the first value of our list. If I want to get the last value, which is true, I can do this. I can start using negative numbers. In our case, if I use negative numbers, this one will be index -1, this one -2, -3, -4, -5, -6, and all the way down. So let's try bring here -1 and hit Control B. I get true, which is the last value here, and by the same matter I can just put here the length of this list, which will give me the last number. If I want to get the length of this list, I just use this built-in method, which is called len, stands for length. I open my brackets and I put the name of my variable and hit Control B. Well, in our case, I need to subtract 1 from it, so I get the last one, which is true. And if I subtract another number, I get this value over here, and so on. If I want to remove this one from here, I can do this. I can just use the del. The del keyword deletes a variable or an object in Python. Anything that you want to delete can be deleted with this keyword. Like for example, I want to delete this 5 from our list. I just have to put del here and refer to the list I have, which is list 1. I want to delete this value, which is 5. I refer to it by its index, which is 1, 0, 1. I put here 1, and here if I want to print the list which has this value deleted, I just put it in here, Control V, and there you go. 5 is not here, it's deleted. and by the same manner I can delete it using another method which is built in. It's called the dot remove, or just remove. I call remove, and I put here the value, not the index, the value that I want to remove. I want to remove 5, so I put here 5. I hit Control B, and 5 is gone. And if I want to, for example, insert a number over here, or just a variable, doesn't matter, in this index, I just refer to the index, which is in our case 1. Here is 0, and here we have 1, and all the other values will get shifted to the right. Like for example, if I come here and I put list 1, insert, I want to insert the string shift, where I want to insert it here in the index number 1, so I refer to the index by 1. Here the position that I want to put this value in, which is 1, which is in our case will be in this position. Here shift will get put. If I hit Control B, I see 3 shifts, and all the other values got shifted. None of them got removed, they just got shifted to the right. Well, that's how it all goes. Also, if you want to remove like the last value of a list, you make use of a built-in method called pop. All what you do is it's called the method pop. Here, and use Control B, and the last value is gone. If you want to store that last value in a variable, you just put here the name of some value, like last value. You assign to it this value that comes from this list. I pop the last element in here, and if I want to print it, I just print it. Control C, Control V, Control B, and here you are. You have true in here. The value that gets removed from here is stored in this value, which is printed here, and that's how it goes. Also, if I want to get, like for example, only this portion of our list, it's easy. I just have to start from this index and end my new list in this index. Well, here we said that this is 0, this 1, 2, 3, 4, meaning that I have to start from 1 and end my other list in 4. If I want to do that, I just create another list. Let me call it list 2. I refer to the first list, which is list 1, and as we mentioned in the previous video, we start from our starting value, which is indexed 1. We put this column here that separates the values we want to go through, and we will stop at 1, 2, 3, 4. I put 4 over here, and I should get this portion. Let's print it to see what do we get. List 2. Here's Control B, and I get the exact same thing. Alright, you can do a lot of other stuff with your lists, of course. For example, if you have a list that contains only integers, for example, int list that contains nothing but numbers, it doesn't have to be integers only, they can be doubles too. I mean floats, just decimal numbers. 1, 2.3, for example, 9, 10, 20. If I want to get the minimum number here, which is in our case 1, I just make use of the min built-in method, which is print min, and I put the name of the list inside, which is this one here. I paste it. I mean, it's straightforward. Everything is self-explained. I print the minimum value of this list. If I hit Control B, I get the minimum value, which is 1. If I want to get the maximum, then you might have guessed this, I just use the max keyword, which gives me the maximum value that is contained in this list. I hit Control B, and I get 20, which is the biggest number here. And that's how it all goes. Alright, we said that we can add lists together in the previous videos. We can delete from our list, we can insert, we can, like for example, refer to a variable by its index. Let me delete these ones first. Here, for example, if I want to get the number that has index 3, In our case, that would be 0, 1, 2, 3. If I want to get this value by its index, all what I do is this, and I refer to the uh, to the to the list, of course. Here, index, the index of this one here, which is 9. Let's control B, and I get 2. And that's the index of 9. 0, 1, 2. Well, from the truth, all what has to do with lists doesn't end here. If you want to know more and more about lists, then you definitely have to check the documentation that is provided by python.org. I'll leave the link in the description below, so I really suggest you to go and check it out. It has a lot of useful methods and utilities and properties that has to do with lists in Python. There are a lot of stuff, endless, I guess. So you just go and check the websites and do some reading. Don't be that lazy, and hopefully you're going to understand everything there. And if you have some struggles and didn't understand something, then please feel free to leave a comment below, and I'll be more than happy to make a video especially for you. So this is it for this video, and the next video will be tackling tuples, and the one after it dictionaries, and we'll make some examples and quizzes after that, so just to let the notion sink in even more. In this video we're going to go through tuples. Well, what are tuples? If you know what lists are in Python, then you technically know all what you need to know about tuples, except some facts that we'll cover here in this video. First of all, tuples and lists are sort of the same. They get defined in a sort of similar way. The way you define a tuple in Python is as follows. You put here some variable name, whatever name you want to name it, and instead of putting square brackets like we do with the casual lists, instead we just open two brackets, and here you add your items in whatever order and whatever type, just like this. Of course you can print it just like you can print any variable and any value. Yes, Control B, I get here the tuple with curly brackets inside of square. And the thing is, the difference between tuples and lists is the following. Lists are mutable while tuples are immutable. What does that mean? Well, tuples cannot be changed or modified. They just cannot be tinkered with. While lists, lists you can do whatever you want to them. You can change an index, you can insert, you can remove. But tuples, once they're defined, they are as they are. They don't change. Like here, if I want to assign a new value to the first index, which is 0, I want to, instead of this 1, I want to add like 100. Here I assign 100 to it, and I hit Control B. In usual lists, this one is supposed to change into 100, right? But here in a tuple, it just gives you an error, as you can see here. And the error we get is here written in plain English: tuple object does not support item assignment. If you can't understand this, then yeah. Anyways, so as I said, you cannot assign anything to any value, whatever index you give, it just doesn't change. It's all the same. Also, you cannot remove a value from a tuple. Like if I try to remove this 4 from the tuple, I simply get another error, which is also in plain English, which says tuple objects has no attributes remove, which means all the remove and inserts and other functions that you can run on lists, you cannot do with tuples. That's not how things work with tuples. Once they are defined, they just stay as they are. They are constant. Usually use tuples for data that is very important, and for sure you're not going to be changing like credit card IDs and stuff like that, stuff that are, you know, like very 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 significant and cannot be tinkered with. You know, once you define a tuple, it stays as it is. Here, if I try to insert some number here, insert number 10 and position index 2, I hit Control B, I get this one again. Tuple object has no attribute insert. Well, that's basically it. Tuples are like lists, but they cannot be modified or changed. They are immutable. Immutable means unchangeable. Like lists are changeable. You can change them, assign new values to them, remove from them, insert to them, do whatever you want with them. But tuples are constant. They are, well, you can just recognize them by these brackets here. You don't use like square brackets like we do with lists. We just use brackets here. And that's it. These are tuples. Well, this is it for this video. We just wanted to define what our tuples are. It's really easy to understand. I mean, you can print like a, you know, you can read the tuple. You can print any value you want that belongs to this tuple. It doesn't matter. You can just call it by its index, like we do with lists. Like for example, I want to get this last value. I get by its index 0, 1, 2, 3, 4. I type 4 here and Control B. Well, 0, 1, 2, 3, 4. Let me see what error we have here. Tuple has no insert. Yeah, that I gotta comment this one first. And Control B. I get this string here, just like lists, but you cannot change them. You can read lists. I mean, you can read tuples, read from them, but you cannot write to them or modify them or just update them. That's it. This is all what you need to take from this video. Well, in today's video we're going to be talking about dictionaries. Dictionaries are another method of storing data. It's another collection, just like lists and tuples, but here the syntax differs a little bit. The way we declare a dictionary is as follows. First of all, you give a variable name, or whatever variable you want to name it. Let's call it dict with double T, because the dict keyword is reserved in Python. Do this equal sign to assign a value to it, and you just open these two curly brackets, and inside you have to give it a pair value, key value pair. That means that you have to give a key and a value that represents one value in a dictionary. Like for example, if I want to give here values or dictionary, I give a name and I tell it what name it is. Like for example, Mike, like this. Here I have the key, which is name, and its value is Mike, and you can give as many values as you'd like. Doesn't have to be one. You separate him with this comma, and here for example I can tell him his age, and for example 16. As you notice, the type doesn't matter. You can put here an integer or a float or a string like we have here, even a tuple or a dictionary or another data structure. Doesn't really matter. You can put whatever you want here. It's completely for you to decide. Well, let's add another value here, or about last name, and give it something like George or whatever you want to give it there. Well, this is how we define a dictionary. Now we have a dictionary that has three values: the first one, the second one, and the third one. Here we have the first one has a key called name, which have a corresponding value of Mike. The second key is age, which has a corresponding value of 16, and the same thing goes for last name, which is Giorgio. I just picked this name at random. You know, I don't think there is a last name like Giorgio. Anyways, if we want to print it, we do just the print function that we mentioned in every single video. Control B, and you have your dictionary right here. As you can see, it gets printed exactly as it is declared right here. But if I want to like access just a certain item in our dictionary, I have to refer to it by its key. Like if I want to get the name here, which is Mike, I do the following. I refer to the dictionary by its variable name. I open this square brackets, and here instead of putting an index like we used to do with lists and tuples, Here we pass it the key that we want to get its corresponding value. In our case, we want to get Mike, so we put here name. I hit Control B and I get Mike because it is the only item here that has a key called name. And the same goes for all the other ones. For example, if I put H here, I hit Control B, I get 16. And that's how you access data. For example, if I come here, let's create another dictionary. Let's see. Let me copy paste this one. This one, this two. Oh, let me call it person 1, and this person 2. So the variable name has some meaning. Name Michael, let's give it like Mea. Age, let's see, 15. Last name Georgiana. Yeah. For example, I want to access the person 1 and access the person 2 at the same time. I can do like this. For example, I have here a full sentence. Let's give it this variable. We're not that lazy, are we? Here I can go person 1. Here I can access its name, and let's create a full sentence. Person 1 says hello to. Let's add our plus sign out so we can concatenate our strings, and to add our person 2. We also want to access the name. Here I guess it is a self-explanatory. I'm saying that person 1, which is Mike, says hello to person 2, which is Mia, because I am getting the asking for the value that has a key, which is name. If I want to print this, I just do print like we always do. Full sentence, I hit Control B and I get this Mike says hello to me. And in the same manner, you can access all the items you want. Like for example, if you want to say that's a person 1 of age, let's do this. Of age what? Here we have it like an integer, so we'll have to cast it into a string. The way we do that is by opening this two brackets here. We put the variable that we have inside here, so it's like it gets converted into a string. In our case, we want to access this one, which has a key of age. Therefore, I gotta copy paste this one, put it here, and access age. Here I'm saying that person 1 of age 16. Here some space says hello to person 2. To do the same here as well. And before I forget, I'll have to add a plus sign here. Let's see that everything is on point. So I have person 1 of age, we say the age, says hello to person 2 of age, and here I want the age of the second one. Here if I hit Control B, I get Mike of age 16 says hello to Maya of age 15. Just like that, we're manipulating these dictionaries and getting the data that we want to get access to. Well, this is how we read dictionaries. If you want to like add some items to your dictionary, like for example here we want to add the school that they attend or the city where they live, we can do like this. Let me comment these 2 lines. Here I want person 1, I just do like this, person 1. Here I enter the new key that I want to add to my dictionary, and let's add city equals, and here let's add a city like Paris. And if I wanted to see my changes, I'll print the dictionary once again. Here, as you can see, city, which has a value of Paris, get added to the end of our dictionary. But if I came here, for example, and gave an existing key that key will have its value getting updated. Nothing will get added to the end. Just here I'm saying that update the name that I have here. Instead of Mike, give it this value over here. It will get overridden. So when I hit Control B, I see that name instead of Mike got changed into Paris, and here age 16, last name Giorgio, and because I haven't saved my changes, I see that the city here isn't isn't here. Well, the same can be done to the second one, of course. For example, I can come here, I can give it a city. I'll see that our Mia is living at a let's say like it's to Mexico, for example, or Texas. And this is gonna be a state. I hit Control B. Oh, I want to print person 2. I get the name Maya, age 15, last name Georgian, and state Texas. Just like this, you add values here. And in the same way, if you want to remove an item from your dictionary, you can do the following. For example, we want to remove this last name from person 2. I just come over here. Let me print it first to see my changes before and after. And here I do like, what do I want to remove? I want to remove the last name, so here I access my data, and before I add this keyword del, stands for delete, del person to last name. That means that I want to have all of this deleted. Here if I print it once again, I can see my changes on the screen. I hit Control B. As you can see here I have last name Georgiana, but here it doesn't exist because I deleted it before I print it once again. Oh well, that's it. There are other stuff you can do with dictionaries, of course, but these are like the very basics. You can do a lot of stuff with dictionaries. I mean, the possibilities are almost endless. You can just go to the documentations, and you'll be amazed of the amount of stuff you can do with dictionaries. You can also add them, together, like add a dictionary to another dictionary, or remove some stuff from them if they are duplicated or something. And we'll get to do that in the upcoming videos. In this video we're going to start the real programming, because we're going to be talking about if statements. So what are if statements? Every programming language has its own kind of if statements. If statements is something that tells you if this operation is right, do this next block of code, otherwise execute the other block of code. It's just a way to tell the compiler if this is right, do this, and if it is not right, do the other thing. Just a way to like differentiate between stuff and specify which block of code should be executed. Well, for us to understand this, we'll have to make some examples. You first start with typing this keyword if, and you give it a condition that results in true or false. If it results in true, that means that the next block of code will get executed. Otherwise, the next block of code, which is prefixed with else, will get executed. Here, let's give it something that results in a Boolean value. A Boolean value is true or false, like we mentioned in other videos. For example, we're going to say if 1 is equal, like the same as 1, execute what's here. Let's see, 1. Otherwise, execute the other thing, which is not 1. If I hit Control B, I see that the result is 1. This block of code got executed because this thing resulted in true. If it did like a result in false, for example, I gave it 3, 1 is equal to 3, which is impossible. This one will get ignored, this line right here, and the other one will get executed. So we should see not 1 printed in the console. I hit Control B and I see not 1. Of course, we won't be using static values like this. We'll be using variables that store data inside of them. So here is what we're going to do. We're going to write a small program that takes a like some data from the user, and based on that data we're going to decide whether we should print true or false. The way you get your data from the user is by making use of the input function. The input function just takes data from the user. In our case that will be we, of course, but this is pretty much advanced, so we'll just use some predefined dummy data. Let's see, for example, we have a number here. It just gives a variable name of number. Let's give it 12. Here we're going to do a test. We're going to say if number is a like an even number. The way you check if a number is even or odd is by doing the following. We make use of the modulus character. We say if number modulus 2 is equal to 0, that means that if this number, which is 12, excluding all the 2's that it includes, the result is 0, that means it's even. Print that our number is even. Otherwise, if it's not even, it should be, you guessed it should be odd. Here, if I hit Control B, I see even printed on the console because 12 is even. If I for example, give it the number 13, which is odd, I get odd here. If I have more than one condition, I can add another block here by saying elif. It stands for else if. Instead of saying else if, we just take these two letters and create the word elif. In other programming languages, of course, you use the else if like that completely without excluding any others. So let's do another check. We have for example a number 13. We say if it is even, print even. If it is odd, print odd. I guess these are the only two things that we can check. So let's do another check. We have a number here. We can say if it is positive, greater than 0, print positive. Positive, and if it is less than 0, print negative. And the only option that is left, that if it is not positive or not negative, then it is strictly equal to 0. That's the only option that is left. So all we have to do is to hit Control B, and we see positive printed here because 13 is positive. If I put a negative sign here and I hit Control B, I see that this is negative. If I put 0 here and I hit Control B, I get this value here, which is 0, equal to 0, because I have 0 here, self-explanatory. And of course you don't have to use like condition directly typed here in front of this if. You can store the boolean value that's going to come out of this condition in a variable, and just put the variable here. We can, for example, let's go back to our even and odd condition. We have a number here, let's see 54, and here we can say is even. This is a variable that I created myself. Here we see whether it's even or not. As we did before, we check whether it is even or not by using this modulus character. If number modulus 2 is equal to 0, that means that our number is even. Here we just put if, and directly we typed our variable. If it is even, we print even. Otherwise it is odd, just like that. I hit Control B and I see even, because this is even variable stores the boolean value that comes out of this condition. Well, these are if statements. We have the if this pass keyword basically means it's like a placeholder. If you have nothing to type here, it just you just type pass, so you don't get an error. It doesn't do anything. It just takes the place until you have some real code you want to type there. Elif and else. With these three keywords, you can check whatever condition you have. You can use it in other stuff as well, not just checking whether a number is even or positive or negative. And we're going to go through those, of course, once we start creating real projects. Well, this is it for this video. We just talked about if statements. We saw how do they work. They basically just take a boolean value. You can't, like, for example, say if and give it here an integer value or a string or something like that. You must give it a boolean value, because based on that result that comes out of that boolean value, whether it's true or false, the next block of code gets executed. And of course, it doesn't have to be just a print function. You can, like, for example, add something here, or just execute whatever code you want to execute. And that's it. These are if else statements, and in the next video we'll be talking about some other topics. Perhaps we'll be talking about loops, so stay tuned. Hello there everyone, hope you all doing fine. So in the last video of this Python tutorial series, we talked about if statements in Python. We explained the fundamentals that we need to know, and in today's video we're going to go through 5 examples to be exact, to let this notion sink in. So our first example using if statement is gonna be this one. We have to check if two integers are equal or not. This is a very simple one. First of all, we gotta define those two integers. As always, variable 1 will take the value of some integer, and another variable, let me just give it another value for now. And if I want to check if these two values are equal, all what I have to do is to use the if statement. I gotta say if var1 is equal to var2. In this case, print they are equal. Now see, both numbers are equal. Otherwise, you can print not equal. And that's it, really simple. If I hit if10 now, I should see not equal, because they are not equal. But if I change this number to 343 and I hit if10 again, both numbers are equal, which is exactly what we want. Alright, let's comment this and go to the second one, which says check if an integer is even or odd. We already did this example the last video, but nothing wrong with repeating the same example. We need to take two variables again, or maybe just one. So let me get rid of the second one here and comment this one. And alright, let me give it a value of 10. 10 is an even number, so if I do if var1 modulus, where is the modulus symbol, modulus 2 should be equal to 0. That means if I take all the 2's from 10, then all what I have left is 0. If this holds true, then this means that 10 is an even number, and therefore I gotta print even. Otherwise it's gonna be odd. I do odd. Again, I hit F10, I see even, because 10 is even. If I increment it by 1, I should get odd, because it's odd. Exactly what I get. Well, everything's going easily so far. The third one says check if an integer is positive or negative. Same thing like this one. We just have to change the condition. This one here. I'm gonna copy it. Oh, come on, just get copied. There you go. and comment it, and I have to check if a number is positive. All I have to do is to see that it is greater than 0. If it is greater than 0, that means it's positive, otherwise it's negative. But it could be equal to 0. In that case it will be neither positive or negative, so we gotta exclude that condition here. We do that by LF. I say if LF var1 is equal to 0, I print neither positive nor negative. That's it. I hit control, well, I still remember control B because we used to use Sublime Text so far. Now I'm using VS Code. I find this editor way much simpler and advanced. I feel comfortable using this one. I guess I'm gonna be using it from now on. So I hit control, F10, I get positive because 11 is positive. If I put a negative sign here, I should get negative. Exactly what I get. And by the same manner, I do 0 and I get neither positive or negative. Exactly. Well, we're done with this example. Let's see now, what do we have? We have to write a FizzBuzz program. Alright, so how does FizzBuzz work? FizzBuzz is, for example, you give us a number. If that number is equal to 3, it should print fizz. If it is equal to 5, it should print buzz. But if it is equal to fizz and buzz simultaneously, then it should print FizzBuzz. That's how it works. So, for example, I have a number here. Let me print this. I have like a 3. I say if it is a if it is one of the multiples of 3 or the multiples of 5. So the same way we check that a number is odd, we do the same thing except we change 2 by 3. So I say if var1 modulus 3 is equal to 0, it should print fizz, and if it is equal to 5, then it should print buzz. But if it is equal to if it is a multiple of 5 and a multiple of 3 at the same time, then it should print FizzBuzz. So I gotta include both these conditions here. I do this first condition and I say and the second condition. That means that this condition should hold true and this one true in order to the whole condition to give me true. If the whole condition is true, then this line will get printed and it should say FizzBuzz. Otherwise, if it is like not a multiple of 3, not a multiple of 5, and not a multiple of the two numbers, then it should be like another number. Therefore, we don't want to print anything. We just pass. We don't have to print anything. So I'll go for 3 first, and it should give me fizz. Let me expand this a little. At F10, I get fizz. If I make it 6, it should give me the same thing. F10 fizz, because 6 is a multiple of 3. I change this number to 5 and it should give me buzz. Exactly what I get. 15, same way. Yeah, 15 is a multiple of 5 and a multiple of 3. So that means that we have to put this condition first, because when 15 is gone through this if statement to check, it finds that the first condition is true, so it prints fizz, but it didn't reach this one, which means this one should be the first condition to be checked. It's easier, just take this one and put it here and change this to L, this one LF. If I hit F10, I get FizzBuzz. because 15 is a multiple of 5 and a multiple of 3 at the same time. And if I do 5, gives me buzz because this one holds true. And if I give it like a 0, it's if 10. Oh, if 10, it gives me fizz buzz. But if I give it 4, it gives me nothing, because 4 isn't a multiple of 5 or 3 or any of them. So this one gets executed, which is just a pass syntax, doesn't give me anything. Well, this is it, the fizzbuzz program. This is how it goes. Let's see, what do we have next. Check if a character is an alphabet or a digit. This is pretty easy in Python. We have a variable here. Let me give it like a character R, and I have to know if this variable is an alphabet or a digit. Alphabet is like a letter, or a digit is like a number, like 1, 2, 3. I say if var I do dot is alpha. That means if this variable is an alphabet, print what I'm about to do here. Print is alphabet is alpha, and that's it. I hit if 10 is alpha. That means it is an alphabet, because R is an alphabet, of course, and this condition gave me true. But if I change it to a number like 2, this one will not get executed, and I get an error. What for? Yeah, because this alpha, it also works only on strings, therefore I gotta turn this into a string. And it doesn't get executed because it is not an alphabet. This is a digit. So if I do elif var to check if a variable is a digit, all what I have to do is to type the following is numeric. So if this number is numeric, this line will get executed, and it says that is digits. So if I hit if 10, I get is digit, because this one holds true, and this one only holds true when I have a string here, like a letter or something that is not a number. Just like this. If I put something here, I hit if 10, I get is alphabet. I put here a string of numbers, I have if 10, I get it is a digit, which is exactly what we need. And that's it. These are the program I have here. We answered all the 5 questions. I hope you have the if statements understood now, and if there is any ambiguity and something you didn't understand, then please feel free to contact me through social media or leave a comment if you want, whatever you want. So this is it for now. Next video we're gonna talk about loops and iterables. How do we use while loops or for loops? If you know about them, then that's gonna be fine. We're just going to touch upon them, and if you don't, then we're gonna talk about the basics. They are very basic, and you can understand them easily, just like you did understand if statements.
So in this video we're going to go through loops, which are essential for any programmer, as they allow you to repeat a block of code multiple times. Python provides several types of loops, of course, each with its own purpose. In this tutorial we will cover the following. These are the while loops, for loops, and the nested loops. So let us get started. I'm gonna start out with the while loops because they are the easiest ones to understand. Let me add a comment here first. While loops. Yeah, so while loops are used when you want to execute a block of code repeatedly as long as a certain condition is true. Yeah, here is an example. Let us define the while loop. You do it this way. You just type the while keyword. You give a condition here. Let us define a count variable first. Let's give it an initial value of 0.
Here I'm saying as long as the count variable has a value smaller than, let's say, 5, execute the following code. In our example, we're just going to print the following text. Well, count is currently, and some space plus count. And since it's an integer, let's convert it into a string. Yeah, this way. What am I saying here? I'm saying that I'm having a count variable here, has a value of 0 initially. Here there is a condition, count is smaller than 5. That means that as long as count is less than 5, the following line is gonna get executed. Once count becomes greater than 5, for example 6 or 7 or any number greater than 5, then this following code will not get executed. And for this to work, we have to increment the count in every iteration in the while loop. So here, after we print the count is currently well, the count value, we're going to be incrementing the count variable by a value of 1. This is how increment by 1. So yeah, I think it's finished. I'm just gonna save the file and come here and execute it. Here you go. I have the count is currently 0, 1, 2, 3, all the way to 4. Wait, that it is not 5 because I think 5 is not included, and we started from 0, so we just have to increment this by 1. And here I'm going to say less than or equal than 5. This way it's gonna go from 1 to 5 inclusive. Repeat this again. 1, 2, 3, 4, 5. Exactly what we wanted. Yeah. Well, in this example, we define a variable count and initialize it to 0, which we did earlier. Now we turn that into a 1. And when the while loop gets printed, the value of count gets printed as well, and increments it by 1 until it reaches the value of 5 and it's no longer less than 5, and that way this condition will not be met anymore and it's gonna exit the loop. Yeah, so there are other types of loops, of course. There are the for loops. The for loops are the most common ones in Python besides the while loops. I mean, they are used most of the time, really. Yeah, they are used when you want to iterate over a sequence of values, such as a list or a string. Yeah, let me give you an example so we can understand. There's the old school fruits list. Let's give it some values here. Gives apple, banana, and why not add another one? Yeah, cherries. I love cherries. So yeah, the way we do this is that we say for, like in the keyword for, we define a variable here, anything, doesn't have to be fruit. You can put an I, which is the standard, or just do fruit like I did here. Well, I'm saying for fruit in the fruits lists, which we defined above, I'm going to do the following with my newly defined variable, which is this fruit over here. Let me just copy it, come here, and let's just print it. Yeah, so what am I saying here? I'm saying that I have a list that contains 3 values, and here I'm iterating through each one of these values and I'm printing the value here. I'm going to, the first one will be give me apple, the second one will be banana, and the third one will be cherry. And once all the values are iterated over, then the for loop will end and my code is gonna exit the for block. Yeah, let me save this and comment the first kind of loop we saw. There you go, save, and let's run our file again. And as you can see here, I have three strings printed out on the console: apple, banana, cherry. Let me clear the screen. Yeah, it's pretty simple really. We just define a list of fruits and used a loop to print each fruit in the list. You know, the fruit variable takes on the value of each element in the list in turn. Yeah. And the third kind of loops which we're going to look on are the nested loops. Nested loops are important, as you'll be doing them most of the time as well. Nested loops. There we go. So yeah, nested loops are used when you want to repeat a block of code multiple times, each time with a different set of values. Yeah, here's an example. We do for I in range. Let's say for example 1, 2, 3. Here I'm just saying that I'm defining a range which will contain values 1 to 3. And yeah, E will be once 1, then 2. I think 3 is not included. 3 is excluded. Yeah. So I may indent by 1, and I'm going to define another loop, which is going to be the nested loop inside of the main one. The second one, let's say G for G, and let's give the same range. Alright, range also 1 to 3. And here I'm going to print the value of I and G. This is how it's gonna be. Print I and G. Yeah, so here's what I'm doing. I'm iterating the first loop, and inside its iteration I'm doing another iteration, which is another complete loop. The first one will give me I, and the second one will give me G, a value. Here I'm just printing the values in a turn. Yeah, so yeah, two nested loops to print all possible combinations, because the first one will be 1 1 1 3, and then 3 1 3 3, I believe. 2 2, I mean. So yeah, it will print the possible combinations of the number 1 and 2. The outer loop iterates over the values 1 and 2, and the inner loop also iterates through the values 1 and 2. Yeah, because it does it over the same values. Yeah, let's see what does this give us. Let me comment this one first. Save, and yeah, 1 1 1 2 2 1 2 2, because first one is 1 fixed, then 1 2, and then 2, because 3 is not included, as we mentioned before. And it's gonna be 2 1 2 2 2 1 2 2. Yeah, clear everything. Yeah, these are the main kind of loops in Python. I believe there are 3. There are other ones maybe, but these are the most important ones, and I'm sure you won't be doing any other ones. I mean, if you just stick with it, then you are good. So yeah, here are the 3 ones, the only ones you're going to need. Yeah, that's it for this tutorial on Python loops. We've covered while loops, for loops, and nested loops, and provided examples of each. Yeah, loops are powerful tools, of course, for any programmer, and mastering them is essential. That's for sure. You know, for writing efficient and effective code. So last video we talked about loops in Python. We went through the 3 essential type of loops. I believe those were while loops, nested loops, and for loops. In this video we're going to do some exercises. We're going to have some problems and, you know, solve them using loops, Python loops, of course. Yeah, so let's start with the first one. We're going to try to make a loop that is going to calculate the factorial. For example, we will use a for loop to calculate the factorial of a number n, doesn't matter what value it has, which is defined as the, you know, as the product of all positive integers up to and including n itself, which means that if we have 3, it's going to be 1, 2, and 3 inclusive. Yeah, the input will come from the user, so we'll be using the input function. If you don't know what the input function is, it's just a function that takes the input of the user from the command line. For example, if I have a variable here called var with 2 errors, I just do input like this, and inside I define a string that I want to appear to take the user's input. Like for example, I can say type your name like this. Please add some space, and here when I receive the name of the user, I just print it out for them. I tell them your name is and what is their names? Let's say var variable that we used. Yeah, we take their names and we tell them your name is whatever they tapped, like if they don't know what their names is. Anyways, so here we type in this looks on new. Here it asks me for my name. Of course, you want my name. Here you go. And your name is Ahmed. Okay, thank you. Duh. Anyways, yeah, this is how we use the input. So we'll be using this input to take the number from the user, and we're going to iterate through it to calculate the factorial. Yeah, let's make a variable here. Let's name it n. Never name your variables in, because it doesn't suggest anything. You should always name your variables. You should give them suggestive names that have a meaning and make your code cleaner. But for the sake of this video, just call it in, like in math. Yeah, the number of course has to be an integer, so we can do some arithmetic calculations on it. Here I'm going to call that function that we did earlier, which is going to take the input. We'll say, for example, enter a number and space. Yeah, so this line basically takes the number from the users and converts this into an integer, because it's going to be a string by default. Next line, I'm going to define a variable. Let's call it factorial, and give it the initial value of 1. And here I'm going to be using the for loop. I'm going to say, like, for I in range it's going to start from 1 and end at n plus 1. The reason why I added 1 here is because if, for example, if we have 3 in this n will not be included here, because if it is 3, then it will stop in 2, because the range doesn't include the number that is here. It includes the number that is below it by 1. So for example, if it's 3 here, I have to increment it by 1 in order to have 4. This way it's going to go through 1, 2 and 3 inclusive. Yeah, there was so much stuff. Now let's add to commas here and indents. Yeah, so each time I iterate, I just add actually I have to multiply the factorial by the value that I have there, because it's going to be 1 times 1, then 1 times 2, 2 times 3. Yeah, considering that n gonna have value 3. Yeah, I guess that's it. We just multiply numbers in order to get the factorial. Nothing hard here. Easy peasy. And of course we have to print the value in order to see if the factorial got calculated. Let's say the factorial of n is, and the factorial that we calculated here. Yeah, let's try our code to see if it's working. Here it's asking me for a number. I'll give it 3, and the factorial of 3 is 6, which is 1 times 2 times 3 equals 6. Yeah, that's correct. We can give it another number, of course, 10. The factorial of 10 is this long integer. Yeah, that was the first example, calculating the factorial. In the second example, we're going to be doing the Fibonacci sequence. Yeah, it is going to be using the while loop, because that is the optimal way to do it. Yeah, we're going to generate the n numbers in the Fibonacci sequence, where each number is the sum of 2 preceding ones. Yeah, old school Fibonacci sequence. Like we did earlier, we're going to take the input from the user. So let me iterate back here, and I'm going to be needing the first line. Let's get rid of everything. Yes. Yeah, I'm going to have two numbers here, A and B maybe. We'll define them in one line. Let's say 0 and 1, because they have to be 0 and 1. And here I'm going to be using the while loop. I'm saying that when A is less than n, which is going to be entered by the user, I'm going to, well, print A and do some arithmetics here. I'm going to give B to A. B will get assigned to A, and B will have the value of A plus B. Yeah, B will go to A, and B will have the value of A plus B in each iteration, and the next time A will have this one, so B will get changed as well, and so far so forth until A is greater than or equal to n. Yeah, and of course I have to save everything, and let's try it. Let's clear the screen first, and Python 3 loves by enter a number. So we got 5. It gives me 0, 1, 1, 2, 3. I guess that's the correct way to do it. And maybe 100, 0, 1, 1, 2, 3, 5, 8, 13. Yeah, the Fibonacci sequence, just like that. Yeah, we initialized two variables, of course, A and B, and to 0 and 1 respectively. We used the Fibonacci sequence by adding A and B there and swapping their values. We print each value of A until it's no longer less than n. Yeah, and this was the second example we had. Yeah, let's do another example, our third example. Let's do prime numbers. Yeah, we're going to be using the nested loops because they are the only ones left, I believe, to generate the prime numbers, up to a user defined number, which is this one here. Yeah, let's get started. We're going to be using the nested loops. Let's define our main loop, which has the I as the variable. We're going to have a range from 2 to n plus 1. Let me continue, and then I'll go through the code. Let's define a variable. Let's initialize it to true at first, and then we're going to have the second defined loop. The range is going to go from 2, and of course we have to turn this into the power of 0.5. That's it. And here I deleted one. I have to check if the modulus of A times Z is 0, because that will indicate it's an even number. Because if it is then it is an even number. It's not going to be prime, because the prime one is only divided on itself and 1, which means this is going to be false. And yeah, I'm going to break out of the loop, and that's it. And here that I have the first one. I guess I have to come here and say that if it's already became a prime, if it is a prime, then well, it deserves to get printed. Print I. Yeah, just like that. Exactly. Yeah, we use the nested loops here to check if each number from 2 to n. We added 1 because, as I said, n is not included, so we have to add 1 in order to include the value of n, the exact one. Yeah, to n. Well, if it is prime, we first assume that each number is a prime. Here we assume that each number we have here is a prime. That's the first assumption before we do our iteration here, because by setting the boolean variable is prime to true, Then we used another loop to iterate over all possible factors of the current number. If the factor is found, we set the prime to false. It's found by saying if I modulus g equals to 0, which indicates that it is an odd number, and break out of the loop, of the inner loop, because this break will just break out of this one, and then we'll come here and see if is prime is still true, because if it's becoming false, that means the number is not prime. But if it stayed exactly as it is with the value of true, that means that the number is prime, is still true. You know, after the inner loop we print the current number here, just like that. So save and check, colored, and let's print. Let's say for example 1, doesn't say anything. Let's say for example 2. So the prime numbers are 2, 3, 4, 5, 6, 7, 8, 9, 11. What am I doing? 11, 3, 3, 4, 6, 6, and 11. I think it's working. Yeah, let's go through one last example, and then let's end this video. Well, here we're going to be counting the characters of a string. The string will come from the user, so we don't have to have the int here. It's going to be a string. I don't need it to be converted into an integer. Let's change the number to maybe for example s for string. Enter a word. The user will enter a word, and we are going to tell him how many characters that word contain. Let's define a char here. Enter character, space it. We're going to be using a normal for loop here for say and s for each character in the string that is entered. I'm going to say if the character is equal to the character that the user wants us to count its the number of its existence in the word above. If it does exist, we're going to increment the count by 1. Just like that, and eventually we're going to print. I'm going to do some nice syntax here. Yeah, the character, or am I doing char? For example, appears. And we're going to tell them how many times. Times in the entered word, just like that. Yeah, we are asking the user to enter the input here, a string, and also another input, which is the character. We use the for loop to iterate over each character, and whenever we find the character that the user entered, we're going to increment the counts, indicating that we have met it again in the word. So save everything, and let's test this. Enter a word. Let's do for example banana. I'm going to be counting how many in characters are there. The character in appears 2 times in the entered word, which is correct. Yeah. Well, you guys, this is it. This is the end of this video. We went through, I believe, 4 or 5 examples. I believe by now the loops should sync in your mind, and you know, with enough practice and examples, it will have no choice but to sink in your mind. Yeah, just make sure you practice all the time, and don't get lazy all the time, because when you do that, you tend to forget some code, and it really sucks having to memorize it all over again. Today we will be diving into fundamental concepts of programming. We will be looking at functions. Functions are an essential tool for any programmer, and understanding how to create them and use them can greatly improve your code readability and efficiency. So what are functions? Simply put, a function is a block of code that it performs a specific task. Think of it as a mini program within your program. Instead of writing the same code over and over, you just define a function and you include the repeated block inside of it, because this way you keep your code clean and as we like to say, dry, meaning that you don't repeat yourself. You can write a function and call it whenever you need. Yeah, the syntax of a function is like the following. Let us write a basic function. We do def, and you give it a name, any name you want. For example, first function, just a made-up name. And here you do something. For example, we're printing something like hello from function. Alright, so what am I saying here? I'm having a function here named first function, and inside of it I'm only printing a string that says hello from function. That's all I'm doing. This is our code. Nothing's supposed to happen because I'm not calling the function, but I want to show you that first. Let's go for by. As you can see, nothing happens. I don't get any results because in order for this function to get executed, I have to call it outside of the function block. For example, I call it with its name, which is, well, first function, and we end this with this two brackets. Oh, just like this. And now if I do the same thing, I get hello from function because I called the function here and I got inside of it and did whatever is written inside. Yeah, so there is this def. This doesn't appear because of the IDE. What is like the def keyword here, and then the name. The def keyword is used to define a function followed by the function name, which we have here. We can also pass some parameters here, like I can pass some data from here and receive it here and use it inside of the function block. Let's for example, well, let's enter something like give it a parameter, and here I can print the parameter that I have. And here when I call the function, I have to pass that parameter in the inside of the brackets. For example, it's type dope coders save. I'm supposed to get hello from dope coders, which I get. There's an extra space here which is unneeded. Exactly. So what's happening here? I'm just having a parameter. There is a it's like a variable that is defined inside of the function, and here I'm giving it a value. I'm assigning a value to it so that it is executed. It's of course the parameter is optional. You can give it or just ignore it. You know, if you need the parameter, you just add it, and if you don't need it, then you don't use it. Yeah, it can be used to pass data into the function. The code inside the function is indented, of course. Here we have 4 indentations. You can customize these based on your IDE. I have 4 spaces here as the indentation, because as you can see, it's like a loop or if statements. You have to keep a certain number of spaces here in order to indicate that this over here is a block that belongs to the function, which in our case is called first function. Yeah, there's another thing about the function is the return keyword. The return keyword is like a thing that we do in order to send the value back to the caller. For example, here I have first function, I'm passing a dope coder. If I want to return this string instead of printing it, I can just get this value first. Let me copy this, go down, and I do this like return, and I tell it whatever I want to return here, and it's at like this. I have an extra one here. This one is supposed to go here. Almost here, just like this. Yeah. So what am I saying? Let me get rid of this one. I'm given the parameter and I'm returning hello from parameter. So here, in order for me to see the returned value, I have to store it in a variable. Let's call it results, and let's print our results. Alright, supposed to be getting the same thing. Exactly. We're just using a return statement in order to return the value back to the caller, nothing more. Yeah, well, let us do some examples in order to get this notion really understood. Let's look at an example of a function that adds two numbers and returns the result. Let's call it add numbers for short. As we mentioned, we do the def keyword, then the name of the function, which is in our case add numbers. Add numbers, we're going to give it two parameters this time. The first number, let's call it num1, and num2. We separate the parameters by a comma. Yeah, and we do our column, and we indent by four spaces or a tab. Then let's define a variable. It's called sum, because we're going to calculate the sum of these two numbers, and give it num1 plus num2. Straightforward. We're just adding these two numbers and storing them in the sum variable. And now I have to return this sum in order to receive it. Return sum, just like that. So if I want to test this, I can print it directly. I'll just use add num and pass it two numbers, example 2 and 5. I can repeat the function as many times as I want, and this is where functions come handy, because you can reuse them and give them different arguments or parameters each time you need them. Alright, save, run. Alright, looks like we made a mistake somewhere. The name I isn't defined. Yeah, my bad. Here, let's test again, func_by, and I get 797, which is the sum of the following numbers over here. Yeah, it's really simple. I mean, I believe the code is understood. All we did is define a function called add numbers that takes two parameters, num1 and num2. The function adds these two numbers and returns the sum. We can call this function, of course, by passing the parameters here. Yeah, values 2 and 5 here, 6 and 3, and here we pass 4 and 3. Yeah, just like that. We're passing the values and storing them, and where we didn't store them, we just printed them directly to the terminal, because if we want to store them, we could have used some kind of variable like result, and then call the function here, add numbers, and pass the two numbers here in here numbers, and then we could have printed the variable that stores the results of the function that we called, like this, print r Yeah, well, basically this and this is the same thing. Yeah, just like the output is shown here. Yeah, well, of course there are two other types of functions built in, and others that are defined by us. They are user defined functions. The built-in ones are like the ones that we used in previous videos. Let me comment these. Examples of those built-in functions are the inputs function that receives data from the user. This one is a built-in function. It's already defined in the Python library. It comes with the Python library. All we have to do is to use it. Here we just call it, and the string that we pass over here is considered to be the parameter, because it uses it in its processing in order to receive the data from here in the CLI and stuff. Just like that. We also saw some other built-in functions like the len function, which we use mostly with arrays and tuples in order to calculate the count. Yeah, there are a lot of other ones. I mean, the print statement is in itself a function. You pass it some parameters and it prints them out.
So that's it, guys. It was a long tutorial. Hope you enjoyed it and learned something from it. So yeah, next up we're going to be talking about object-oriented programming. I'm going to start out a series pretty soon. Yeah. So thank you so much for watching, and don't forget to subscribe to support the channel. Yeah, take care.